I'm Adam.
Hi, I'm Nacho.
We're both software engineers working at Google on Knative, specifically Knative eventing.
This session is about Knative Sources, which is a core construct in Knative eventing.
The previous session is more of an overview of event-driven architectures and Knative eventing in general, and the following session is a deep technical dive on the broker component within Knative eventing.
In case you haven't attended the previous session, let's start with some brief context of Knative. Knative is a Kubernetes-based platform to deploy and manage serverless workloads. It's built on top of Kubernetes with the idea of abstracting away complex Kubernetes details from developers to enable them focus on what matters most, their business logic. It has two core components. One is Knative Serving and the other one is Knative Eventing. Knative Serving allows for rapid deployment of stateless HTTP containers. It supports auto-scaling of those containers from 0 to n, and it also deals with routing and managing traffic splits during deployment. For example, you can deploy a new version of your service and you only want 10% of the traffic to go there, then 20%, then 30%, and so on. You can use Knative Serving. Knative Eventing, in turn, takes care of the subscription, delivery, and management of events, and it enables event-based triggering of your workloads.
Both Knative Serving and Knative eventing are great on their own, but they also complement each other well. Using them together means that you can easily have Knative Serving respond to things other than direct HTTP requests, and allows eventing to automatically scale up to the peaks of demand and scaling down to zero when no demand is present. Knative eventing is made up of composable primitives that allow late binding between event sources and event consumers. Whenever we speak about an event inside Knative eventing, they always follow the CloudEvents standard. Event sources produce cloud events while event consumers consume them. Broker and trigger are intermediaries that allow interested event consumers to receive cloud events without the source having to know about each individual consumer.
As mentioned in the previous slide, Knative Eventing speaks cloud events, and these give us some advantages. One is consistency, because the lack of a common way of describing events would mean that developers will have to write their own event handling logic for every new source. The other one is accessibility. If you think about it, if you don't have a common way of expressing events, it means that there are no common libraries, no common tooling, and no common infrastructure for delivering event data across different environments. It's worth noting that Cloud Events provides several SDKs in different languages, such as Python, Go, JavaScript, etc. And the other advantage is portability, because your containers can be moved to other environments that also are Cloud Events friendly. Cloud Events have contact attributes and data. You can think of contact attributes as metadata. Um, the contact attributes are designed in such a way that they can be serialized independently of the event data. This allows them to be inspected without having to deserialize the data, for example, to make routing decisions. Here we see an example where we see some context attributes such as type or the source where the event came from, the spec version, and so on. There are also multiple protocol bindings that define how to map an event to a specific protocol message. For example, the HTTP protocol binding for cloud events defines how cloud events are mapped from HTTP requests and response messages, or the Kafka protocol binding, which defines how you can map events from Kafka messages to cloud events and so on. Given that general background, we can now focus on the main topic of this session, which is Knative Sources. Here's the proposed agenda for the talk. We will start with what are Knative Sources and why we need them, as well as some of the design choices we made along the way. We will also go over some of the sources that are available out there for you to use. And we'll also go over more details on how you can implement your own source if none of the available ones fits your purpose. And we'll finally conclude. So let's get started with Knative Sources. But let's start with the fundamental question of why we need Knative Sources. And the answer is pretty simple. Knative Eventing adopted the usage of cloud events. However, most producers still use their own event formats. So there's an impedance mismatch. We need Knative Sources to be able to leverage existing known cloud events producers into this cloud event world. And if we want more breadth of producers, then we need something that would allow us to convert event formats into cloud events. And breadth is very important here because at the end of the day, eventing systems, regardless of their quality, are limited by the events that are available to them. What are Knative sources? Knative sources are constructs that produce or import events into the cluster as cloud events. They convert incoming proprietary events into cloud events and sends them downstream. And downstream can be any HTTP addressable. We also call them sinks. For example, it can be an end consumer, such as a Knative service, or a middleware, like for example, the Knative broker.
We talked a bit about the why, the what. Now let's delve more into the how. Specifically, how are Knative sources implemented? Knative is designed to be as native to Kubernetes as possible, hence our name, Knative. Knative uses the standard way of extending Kubernetes, the custom resource definition, or CRD. CRDs define new resource types similar to a class in a programming language. We then can create instances of this CRD called a custom object, or CO. These are similar to instances in a programming language. If you would like more information about this, the link below has the official documentation about CRDs. Broadly speaking, we have two types of sources, push-based sources and pull-based sources. Push-based sources are ones where an upstream event producer pushes an event into our source, such as GitHub source, where GitHub makes a HTTP request to our source. This has the downside that we must expose an endpoint for our source to hit. It doesn't necessarily have to be on the public internet, but it does have to be somewhere that the producer can reach. One of the large upsides is these are much easier to scale. We can leverage things like Knative Serving, which already does this, to scale up to meet demand and scale down to zero when there isn't any. Pull-based sources, on the other hand, are pulling events from the upstream producer. They can either be doing so on a continuous basis or on a periodic basis. They need network access to the event producer, but they don't necessarily have to expose an endpoint themselves. In general, these are more difficult to scale because we need our own way to define how congested it is. It also means that something is either continuously running or at least periodically running in the background. While developing Knative, we tried two different CRD models for our sources. The first we tried was called the provisioner model. We had a single CRD named source. Inside the specification of that CRD, there was a field called provisioner. Every custom object that was made would fill in that field, and that field would determine what kind of source it was. It might be GitHub or Kafka or something else. This made it very easy for our Knative core code to interact with sources. There's only one type, and we knew it at compile time. This tended to work pretty well as long as the parameters for our sources were very similar. As the number of sources increased, the parameters started to diverge. We had to add a generic parameter map. This made it very difficult for users to understand what they needed to configure or what even could be configured for a given source type. It was also more difficult to figure out what sources were even available to begin with. The next model we tried was called the operator model. In this model, each source has its own CRD type. For example, Kafka source, MongoDB source, and GitHub source are all their own CRDs. This made it much easier for users to understand what was installed in the cluster because they could use their native Kubernetes interactions, such as listing CRDs. It also made it much more straightforward for users to understand how to use these sources because they could introspect the CRD itself, which told users exactly what fields and parameters were available for customization. The big downside of this was that our Knative core code had to deal with objects at runtime that didn't know about at compile time. In the end, we decided to take that extra complexity on the Knative core code and make life better for our users. We decided to go with the operator model.
Although we went with the operator model, where we have different CRDs for different sources, we also wanted to have all sources share some similar shape. This would allow us to treat them polymorphically in code, or for instance, a cluster operator will be able to inspect the resources without having to be fully aware of the implementation, and it will also allow us to build common libraries that could be reused all over. For this, we use duck typing. Duck typing in Kubernetes world is a technique that allows you to define a partial schema of an object. In the example below, we see three JSON objects. The one on the left-hand side has a foo and a bar property, the one in the middle has a bus property, and the one on the right has a spam and a ham property. But all of them, they have this same Knative property, which has eventing and serving. And if we want to reason about that Knative property in all of these different resources, we can use duck typing. We can use duck typing to extract that partial schema. And that's exactly what we did with our sources. Although we have different CRDs and each CRD has specific attributes, all sources share a partial schema. They all implement what we call the source duck type. Here I'm showing three different objects, a Kafka source, a ping source, and a MongoDB source. Although they are different, you can see that they all have this sync attribute marked in red, where the sources can specify the sync where they will send the event to. They also can optionally specify a cloud event overrides, which is in dotted red rectangles there, which are attributes that are added or overridden in the outbound events. Although they share these common attributes, it's worth noting that each of these objects define their own specific attributes. For example, the Kafka one, you can specify a consumer group in the spec, or the ping source, you can specify a cron schedule. Even in the MongoDB source, you can specify a database, for instance. Having introduced the operator model and the source duck type, we'll now talk a little bit about what it means to be a compliant Knative source. In order to be a compliant Knative source, you need to conform to the source specification. We added a link here for your reference. Roughly speaking, the spec talks about CRD level requirements and custom object level requirements. Regarding the CRD level requirements, we require the CRDs for sources have a particular label specifying that they are actually sources. They have to have a sources category. They should also have an annotation where they can specify the type of event they can produce. Regarding the custom object requirements, they basically need to implement the source duck type. And it has the spec.sync that we talked about in the previous slide, plus some status condition that allows you to specify whether the source is ready or not, as well as the resolve sync URI.
Now that we've talked a bit about what a source is, let's see what sources are already available. Core sources are the ones that are maintained by the Knative Eventing project itself. We have 4 of them. API Server Source is a source for Kubernetes events, a resource within the Kubernetes cluster that represents the creation, update, or deletion of a resource within the cluster. In order to create an API Server Source, you can specify the highlighted attributes on the slide. The service account name is the Kubernetes service account that this will run as. Because this uses watches against the Kubernetes API server, it needs to have sufficient RBAC permissions to do so. The mode, either resource or reference, describes whether or not the event itself should contain the entire resource that's being modified, or whether just a reference to that resource is going to be in the event. Finally, there's a list of resources that are actually going to be watched. The ping source sends events at a fixed schedule with a fixed payload. This specific example uses the cron schedule for every minute, and it always sends a message with the same data. Message is hello world. Sync binding isn't a direct source, it's more of a meta source. It doesn't generate any events itself, but it makes it very quick and easy for you to make your own sources. It can be used with the pod specable duck type. A pod specable duck type object is one that has the spec.template field that is a pod template. Some examples are deployments, Knative services, and stateful sets. A sync binding turns a pod specable into a source. By providing in the sync binding the pod specable you want to use, it will inject the sync into that pod specable as an environment variable. This allows you to very quickly and easily get an ad hoc source up and running. As we were using sync binding, we realized that by far the most common usage was with the deployment. Container source is another meta source that combines a sync binding with a deployment. By creating this one resource, it will create a deployment with the container image you specify and an injected sync URI. This allows a very quick way to create ad hoc sources.
Besides those four core sources that come out of the box with Knative Eventing, there are other sources that are community owned and that needs to be installed separately. We have things like the GitHub source, which will allow you to listen for GitHub events. For example, if you want to get a notification when a pull request is created in a particular repo to trigger some CI/CD pipeline, you can use this. Or there's the Kafka source that would allow you to receive events when some message is published into a Kafka topic. We also have non-SQL based sources such as CouchDB and MongoDB, where you can listen for changes in databases and collections and act accordingly. For a more extensive list of sources, you can follow that link. Besides the core sources and the community-owned sources, we also have vendor-owned sources. In particular, we at Google have been creating Knative sources for GCP services. For example, we have the Cloud PubSub source, which will allow you to receive events whenever you publish a message into a PubSub topic. Or we also have the Cloud Storage source that will allow you to listen for changes in GCS buckets. For example, when an image is uploaded, in a GCS bucket, you can get an event and trigger some computer vision pipeline, let's say to do object segmentation or image recognition. We also have the Cloud Scheduler source, which will send an event based on a cron schedule, similar to Ping source and some others. Trigger Mesh has been collaborating and contributing a bunch of sources, especially for AWS services, such as SQS, DynamoDB, and Kinesis. And finally, VMware has also been contributing some Knative sources, such as vSphere.
Now that we've looked at some of the available sources, what if there's a source that you need that doesn't yet exist? Let's talk about implementing your own. This is the kind of flowchart we think through whenever we think about creating a new source. The first and most important question is, do you want to make your own CRD? This makes it much easier for users to use your source, but also increases the complexity of building everything. If you make your own CRD, you do need to understand more about Kubernetes and the Kubernetes event model. Regardless of whether you choose to make your own CRD, you will need to write your own data plane, your own container image that sends the events themselves. If you make a CRD, you also need to write a controller as well. This flowchart can help determine what you should do. If you want to make your own CRD, we recommend that you clone our sample source repository and modify it as necessary. If you don't want your own CRD, then can you run your container image as a deployment? If so, then use that container image and make a container source. If not, can you run a container image in any pod speckable? If so, make that pod speckable resource and make a sync binding as well. If not, then once again, we recommend you clone our sample source repo and modify. Sample sources are an example of how to build a source CRD along with its controller and webhook. It follows all of Knative's best practices and is set up to be easily modifiable to get your CRD up and running quickly. For experimentation or just ad hoc sources, we recommend container source or sync binding because of just how quickly you can start. As we mentioned, if you make your own CRD, then you're going to have to implement your own control plane. The control plane is everything involved with getting a source ready to send events, but not actually sending the event itself. It's generally built up of two pieces, the controller and the webhook. The controller will read the spec of every custom object and then write out the status of every custom object, running in a loop forever, where it observes the real world, dispatches against the desired state from the custom object, and acting to make the real world match the desired state. The webhook will default, validate, and convert any of these resources as well. The validation that the webhook does is not on the events themselves, rather on the custom object. It can go beyond the level of validation available in CRDs by doing things like validating if two mutually exclusive fields are there, they are not both present on the custom object at the same time. The data plane is everything involved with sending the actual events. We often call the pod that's sending the events the receive adapter. What it does is it will receive an incoming event from somewhere. This could be an external web request in the case of GitHub source. It could be an in-process timer in the case of ping source, or it could be pulling from an external API in the case of API server source. It will then take this event and convert it into a cloud event. It can make any modifications it wants, including the CE overrides we saw earlier. It then sends this event to the sink that was passed in as an environment variable. And finally, If the original event producer needs acknowledgments, the receive adapter will then acknowledge upstream. The picture we have here is of a pull-based source. The receive adapter is pulling changes from the upstream producer and sending those as cloud events to the sink. CloudEvents provides SDKs in multiple languages. Here's an example of how we can send an event in Go. The first thing we do is we make a client. In this case, we want an HTTP client, and that's what the default happens to be. Next, we make an event. Every event requires a source, a type, and an ID. We specify the source and type here and allow the SDK to default the ID for us. We also choose to add a data payload, in this case, hello world. Finally, we look up what our sink is with the ksync environment variable and send to that address.
With that, we have reached the end of the talk, so let's jump to conclusions. We hope you have a clearer understanding what Knative sources are. In general, eventing sources are a key construct for any event-driven system. A Knative source is an abstraction that produces cloud events and sends them downstream to any configurable sink. Knative eventing comes with some core sources out of the box, but there are multiple Knative compliant sources out there for you to use, both community-owned and vendor-owned. But you can always create your own sources. It's easy to do so, and you don't need to fully understand Kubernetes.
If you're interested in and want to learn more about any of the concepts we've talked about, or just excited to start using Knative Sources, please visit our public docs. If you have any questions, please join our Slack channel. And if you just want to explore our code or our future plans, please look at the Knative GitHub organization. Thank you very much.
Thank you.